So, what do we got here? We got a basics quiz. Let me zoom in on that. Sorry, we have a basics quiz practice. That's what we got here. So this one's a little bit different than some of the past ones. A lot of the questioning is still here, but some of the stuff has changed. First question here is absolute value. In the past, it's been something as a fraction, but now it's absolute value. Because if you can do these, you can do the ones prior. So the first thing I'm going to do is counteract this division of 3 by multiplication of 3. Because I can do that. What you do to one side, you can do the other. They cancel there. 4 absolute values of 2x minus 3 is greater than 12 minus 3x because of the distributive property. Now I can also distribute this 4 in. The absolute value of 8x minus 12 is greater than 12 minus 3x. All right? Now you have to write two equations. I don't know why, but half of y'all are forgetting absolute value has two answers. That has been talked about and talked about and talked about. First one is 8x minus 12 is greater than 12 minus 3x. Or on the second one, 8x minus 12 is greater than negative 12 plus 3x. We change the signs on the stuff outside. We're going to add 3x to the left. That's going to give us 11x. And we're going to add 12 to 12. That's going to get us 24. And then we're going to divide through by the 11. So x is greater than 24 elevenths. Now we're going to do the OR situation. We're going to subtract 3x because if we jump a symbol, inequality or equality, we're going to change sign. And we're going to add 12 to 12. Sorry, we're going to add 12 to negative 12. That's going to give me 0. Divide by 5 and x is greater than 0. Interesting. Now we have two things here. Well, this one would have to win on this example. Might be a poor problem. Alright, assuming I didn't make any mistakes, so let me glance over it and make sure I didn't. Probably should choose another other than 4. But it's done. I don't think I made any mistakes. Well, that looks good. Some of you might understand why I have this little conundrum here. Which one of these is true? Being bigger than 0, being bigger than that. But anyways, just for now, go with both of them. Solve the factored quadratic. And this one is factored for you. This is legit cover-up method. 3x minus 11 is 0 because we use that cover-up technique I've talked about. Or 2x minus 1/12 is 0. This is easy. We're going to add 11. 3x is 11. We're going to divide by 3 and get 11 thirds. Or we're going to jump over. 2x is a 12th. We're going to divide by 2. And I've talked about this in class. You can throw it in the existing denominator. 2 times 12 is 24. So those are my two answers. I'm sorry they're fractions. I know kids don't like fractions, but if you do this stuff in the real world, it's always ugly stuff. The answers are always ugly. I hate it for you. 3 is solved using the quadratic formula because it probably doesn't factor. This one shouldn't. So here's the quadratic formula. It goes x equals negative b plus or minus square root b squared minus 4ac all over 2a. Sorry, I'm a little bit sick. That probably wasn't the best. A is 3, b is negative 4, and c is 2. So opposite of a negative 4 is a positive 4. If you're going to square something, don't worry about its sign. It's going to be positive. All over twice a. So I just plugged everything in. I can give you a point of 3 for that. If you can plug stuff in and show me that, I can give you something. Now 4 squared is going to be 16. 4 times 3 is 12. Take away 2 is 24. So I have 16 minus 24 in my radical. Both pieces over 6. I like to break apart right here. 4, 6 plus or minus. This is going to be the root of negative 8, also over 6. So off to the side in my head, I'm thinking about this root of negative 8. I know that it is imaginary, and you should too. I also know that 8 is 4 times 2, and you should too. And you should also know that the root of 4 is 2. So I evaluate the root of 4, I put a 2 on the outside. There we go. 4 over 6 reduces to 2 over 3, and plus or minus 2i root 2 over 6, which also reduces. 2 over 6 is 1 over 3, so 2/3 plus or minus I root 2 over a 3. 4, the ones we don't like, and I'm sorry you don't like these. In the state of Tennessee, 20% of the student body gets a question like number 4 right. Only 20% of all kids get these right. You know, I know a lot of you kids are struggling, and it's my fault. It's not my fault. It's not. I have to teach this stuff, and I need more than 20% of y'all to get these right. I'd like to see 75, 80% plus, and we're just going to keep doing them every quiz till you do. If you can get these, everything else flows. That's kind of the way this is. If you understand these, everything else makes sense, by and large. Same with number 3, the quadratic formula is huge. For some reason, if kids start getting that, other things start clicking. So anyways, the goal was to solve this for r. Well, I understand that there are multiplier symbols between r squared and pi and h, so I'm going to divide both sides by pi h. That's going to give me equal to r squared. Now I'm going to counteract squaring by square rooting. Now, the square root of r squared is r, so r is the square root of volume over pi h. Not a hard thing. Number 5, this is the FOIL example. I warned you this was coming. You do need to know that I squared is -1. If you don't know that, I can't help you. You have to memorize that. 2 times 2 is 4. 2 times 3i is plus 6i. Negative 5i times 2 is minus 10i. And negative 5i times 3i is negative 15i squared. Now, since I squared is -1, I can replace that I squared with a -1 and I get positive 15. The way I've taught this in class is to change the sign and mark off I squared, because that's what happens. 4 and 15 makes 19, and 6i minus 10i is minus 4i. By the way, the form here is a plus bi. Real number plus bi. You would know that if you hadn't cheated your way through IXL. Number 6, given f of x is 2x squared minus 7 and g of x is 4x minus 5, find f divided by g of -3. It says that's equivalent to f of -3 over g of -3. I know a lot of y'all don't get f notation. Why the f you don't get f notation is beyond me. It's not hard. Cantrell was complaining about seniors in bridge math not knowing how to do it. I mean, we know it's an issue. Garner complains about freshmen not knowing how to do it. It's not your first go around with f notation. You just don't want to accept it. If you take a -3 and square it, you get 9. Twice a 9 minus a 7. Twice a 9 is 18. You take away a 7, you get 11. Now you're going to find g of -3 by plugging a -3 into g of x. 4 times a -3 minus 5. 4 times a -3 is -12. And -12 minus 5 is -17. And by the way, it was f over g. So 11 over -17 or -11/17. I know that throws some kids off, but you can move the negative out front, or you can move the negative to the numerator. It would not stay in the denominator. 7, more average rate of change stuff. We're supposed to find the average rate of change for the function over an interval. So the formula for this is f of b minus f of a over b minus a. And we just plug in. And this is another one of the things you talk to math teachers all over the state. Why can't my kids do average rate of change? I don't know. But we know it's an issue, but mostly it's y'all. You just don't try. To find f of b, I'm going to plug in a 3. So off to the side here, I got to do 3 squared minus 4 3s. That's going to be 9 minus 12. That's -3. Now I got to find f of a. by plugging in a -2. I know that'll mess kids up. That would be 4 plus 8, which is 12. So I've got a -3 minus a 12, because I'm following this little formula right here, over 3 minus a -2. A -3 minus 12 is -15. 3 minus a -2 is 5. This ends up being -3. All right, moving up top onto ACT. A lot of kids, for some reason, still think these are optional, like they just leave them blank. Anyways, not supposed to. How many distinct prime factors are there of 100? So to get to 100, you've got to write down all the factors of it. I'll just start with 4 times 25. All right, that's easy. Oh, by the way, 1 times 4 times 25. Don't forget about that guy. 4 is 2 times 2, and 25 is 5 times 5. It talks about distinct. That means unique. All right? And it is prime. Prime number is divisible by itself and 1 only. And 1 is part of the definition. So these are the distinct prime factors. I know you could make an argument for 4, but it says distinct. There are 2 distinct prime factors. ACT2 is a question from geometry. Back, kids tell me all the time, man, I was good at geometry. No, you weren't. You just had a good grade. There's a huge difference. You weren't any good at geometry. You weren't Milbrath good at geometry. Put it that way. So it's about triangle ABC. That's how they're drawn. It says the measure of angle A is 30 degrees. Angles lie inside a triangle, not outside. And C is a right angle. It says AB is 10 and BC is 5 root 3. What is AC? So I'll show you 2 ways of doing this. All right, the first way is to use A squared plus B squared equals C squared. That's the first way. We'll just call this little piece X. X plus 5 root 3 squared is 10 squared. And it's going to be hard for some of y'all, because some of y'all just can't do numbers. If you square a 5, you get 25, and if you square a square root of 3, you get 3. So this piece right here is actually 25 times 3. 10 squared is 100, and I forgot the square on my X. This is going to be 75. I'm going to subtract it from 100 and give me 25, and then I'm going to have 5. That's the missing leg. The other way of doing this, and it's so much quicker, is to think about 30, 60, 90 theorem. Some of you know it, a lot of you haven't, but in 30, 60, 90 theorem, we call the short leg x, we call the hypotenuse twice x, and we call the long leg we have a typo here. Angle B should be 30 degrees. So anyways, I need to fix that before y'all see it. And we call the long leg x root 3. So I can kind of look at these things and say, I can line up x root 3 and 5 root 3. And what's missing between the pattern and this actual special right triangle is that x is 5. And I hope you can see that too. ACT3, find the value of k such the determinant of this matrix is 5. So the determinant of a 2 by 2 matrix that contains the elements A, B, C, D is AD minus CB. That's how you do them. So I follow that rule here, and I would have negative 5k minus a negative 30 equal to 5. Taking away a negative is addition. Subtract 30 from both sides. and divide by a -5, and my k value is 5. There you go on that one. On to the back side. Find the equation of a line that passes through two given points. By the way, if you can't do this yet, you don't get to blame me. I'm sick and tired of that stuff. It's not me. That's the formula. You learned it. I know you learned it your freshman year of school, and I'm almost certain you learned it your 8th grade year. You find your slope by doing y2 minus y1. That's a 7th grade math standard over x2 minus x1. 6 minus 5 is going to be 1. 5 minus -2 is 7. And I'm just going to use the first point. It's going to give me an x1 and a y1. So y minus 5 is 1/7 of x minus a -2. Taking away a negative is addition, always has been. We're going to invoke the distributive property. 1/7 times x is a 7th of x, and 1/7 times 2 is 2/7. If you don't believe me, go ask your 5th grade math teacher. Now we're going to add 5 to both sides. You know, I notice a lot of y'all just can't do that. I mean, you're doing 2/7 plus 5, okay? If you like mixed numbers, that's 5 and 2/7, isn't it? I don't know if you guys remember, like the old, I think they called it the C method. 5 times 7 is 35, add 2. 37 sevenths. That's not necessarily the way I teach it because, I mean, you're not supposed to be using that really past 5th grade, but maybe it helps. What I do is I look at 5 and I think, oh, that's 35 sevenths. So I'm thinking 2/7 plus 35 sevenths. And I get the same thing either way. I guess it matters which way you do it. But anyways, 1/7 of x plus 37 sevenths. All right, we got a formula here. Write a rule for the sequence, -2, 1, 4. I even gave you the form, so it shouldn't be hard. I noticed that the difference is 3 and that the first term is -2, and I just plugged the crap into that thing right there and I'm done with it. A sub n is -2 plus n minus 1 times the difference of 3. I get to invoke the distributive property. And then I combine like terms. A -2 and a -3 makes -5. All right, given this sequence that a sub n is 2n minus 6, find the sum of the 6th through 10th terms. I don't know how many times I've been over this with you, but for 6 through 10, you just use your fingers. 6, 7, 8, 9, 10. 5 terms. There's 5 terms. 5 terms. So what you can also do is you can do 10 minus 6 and add 1 back, but there's 5 of them. The formula is given everywhere you see n. You are a 5. Well, with the exception of a sub n, you're finding the sum of 5 terms. It's going to be 5 over 2, parentheses. A sub 1 is the first term you care about. So we got to find a sub 6 by taking a 6 and plugging in right there. Twice a 6 minus a 6 is going to be 6. The last term is found by plugging in a 10. So twice a 10 minus a 6 is going to be 14. Last I checked. So inside the parentheses is 6 plus 14, which by the way is 20. Sum of 5 things is 5 halves of 20. Half of 20 is 10, so 5 times 10, and 50 is my answer. Solve this system using the elimination technique, another Algebra 1 standard. Is actually being taught in 8th grade by and large right now. So we shouldn't have a problem with that as juniors. Me, I'm going to take the top one and I'm going to multiply everything by 2, and I'm going to take the bottom one and I'm going to multiply everything by 3. Because I'm trying to eliminate either x or y. Turns out it's actually going to eliminate probably y. But if I double the top, I get 6x minus 12y equal to 48. And if I triple the bottom, I get 6x plus 12y equal to 24. Now I happen to notice that if I add down, the y's will disappear. So 12x is now 72. Seems legit. Divide by 12 and my x value is 6. Now that I have x, plug it back in. So I've got this top equation, 3x minus 6y is 24. I'm going to let x be 6. 3 sixes makes an 18. 24 minus 18 is 6. So negative 6y is 6. And my y value is negative 1. So I get this nice ordered pair, 6, negative 1. Hopefully the last time I ever have to put this thing on here. Use the graph below to determine the average rate of change over the interval negative 2 to 7. Shouldn't be hard. So x is negative 2, I'm right here on the graph. When x is 7, I'm right here on the graph. Now, I am actually rising from negative 4 to 1. I'm looking at these. I rise from negative 4 to 1. So I rise 5. I am running from negative 2 to 7. I run 9. Ta-da! 5 nines, kids. Alright, bonus section, which a lot of y'all just won't do. I don't know why you won't do them. You should. I guess you just want to complain about your grade. So given f of x is 2x squared minus 3x plus 3, find f of x plus h. Don't you step in to dual enrollment next year or pre-calc and not be able to do x plus h. You don't belong in that class. I'm not even saying that mean. I'm just saying you can't do this. You don't belong in that class. Rethink your life plans. First off, everything becomes x plus h. To square something, you write it twice. This piece is easy. That's the distributive property. Now x plus h times x plus h is going to look kind of funky. It's going to be an x squared plus hx, so plus 2hx or plus 2xh, however you like it, plus h squared. That's supposed to be a 3h. And I'm going to have to distribute this 2 to everything. I will get 2x squared plus 4hx plus 2h squared minus 3x minus 3h plus 3. Bonus 2. Given the same function as bonus 1, find the difference quotient, which is also known as the instantaneous rate of change, which is also known as the derivative in calculus. F of x plus h minus f of x, both pieces over h. Now the nice thing is by the time you've done bonus 1, you've done most of the work for bonus 2. And bonus 2 is worth 3 points. So I'm going to take all of this, it goes right there. 2x squared plus 4hx plus 2h squared minus 3x minus 3h plus 3 is this take away f of x. Now f of x has 3 different parts, so I need to invoke a big set of parentheses, otherwise I'm going to make mistakes. Take away 2x squared minus 3x plus 3. All sitting pretty over an h. Now I have 2x squared minus a 2x squared. By the way, when you take something away, you just change its sign. So let's change that to plus, minus, plus, minus. I don't know if that'll help you or not. But you have 2x squared minus 2x squared. That's nothing. You have a negative 3x plus 3x. That's nothing. You have a positive 3 and a negative 3. All that stuff is gone. So you are now left with 4hx plus 2h squared minus 3h, all 3 pieces sitting over an h. Think about that. The 4hx is over an h. The 2h squared is over an h. The minus 3h is over an h. All 3 pieces of the numerator contain an h. Gone, gone. Exponent becomes a 1. So I have 4x minus 3 plus 2h. There you go, kids. Oh, one more. Sorry. Simplify. 5 plus root 3 over 4 minus root 5. We're going to multiply by the conjugate, which is 4 plus root 5. 5 times 4 is 20. 5 times root 5 is plus 5 root 5. Root 3 times 4 plus 4 root 3. Root 3 times 5 plus root 15. Down low, all that matters is that piece and that piece. 4 times 4 is 16. Root 5 times root 5 is 5. It's negative because one's positive, one's negative. 16 minus 5 has been 11 my entire life. I don't know why that would change today. And up top, while all those are numbers, they're all not alike. So 20 plus 5 root 5 plus 4 root 3 plus root 15. Done. There is Basics 11 practice sheet. All I've got to do is fix one little issue. Good luck on that. I think it's Thursday. Yeah, it's Thursday.